You okay over there, Hagen? Well, I doubt that. Oh yeah, I don't know if you noticed behind me or not. Rutley clearly did. Yesterday was a massive milestone. Yesterday marked exactly 1/3 of our school days done. 33.3333% of the school year is done. And today, when I walk out, I will switch one more marble and we'll be down to double-digit days remaining. 99.51. And then about 24 days from then, we'll hit the equilibrium point at 75.75. And I have to pause this so I can answer the phone. So there's really nothing else. There's one other thing I have to say, but I'll say that at the end. There's not any other like fresh meat on the bone today. Today's only real freshness is these. And I'll just caution you, just having done this for a while, this is a struggle and it shouldn't be, but it often is. And I'll explain to you, like I've cracked the code. I get why it's a struggle. I get why people miss it. And I'll try to get in the way of that for you so that you can understand the trap that your brain's going to want you to fall into. It will. Your brain will tell you one thing and you have to say no, brain, and you're going to do the other way. So I'm going to try to show you correctly like why these types of lines are graphed the way they are. And if it doesn't get stuck in your head, then you just, if you don't buy into the whole sales pitch, then you just have to memorize it. And I'm not asking that much, right? So you guys all know what horizontal lines are. You all know what vertical lines are. We have not discussed them yet. All of the lines that we've graphed have been lines like y equals 2/3 of x minus 1, right? So you go down 1, put a dot, go up 2, right 3, like easy peasy. So those are oblique lines. Those are tilty, slanty lines. What we're going to talk about today is the unique guys, the guys that don't tilt, that don't go like up and right or down and right or something like that. They're just more boring, and they should, in theory, be the easiest ones. So if we walk out of here in 10 minutes, or not walk out of here, but if we leave this lecture in 10 minutes and you feel like you got it, then mission accomplished. But it should not be something that's difficult. Okay. So what I want you to do is find me a bunch of points whose x coordinates are 4. And I don't mean you have to graph them right now. I just mean, and we can do this as a team, or you could do it on your own. But what I want is a collection of 4, 5, 6 points, whatever. And the only rule I'm giving you is that I need the x coordinate of the point to be 4. Could someone think of a point that has 4 as his x? If you're stumped, then you're already making this too hard. Hold on a second. I'm going to pause this. So I see that my question vexed you. So let me give you an example of what I mean. Here's a point whose x coordinate is 4. 4, 2. You see, all I did was just pick a point that had an x coordinate of 4. Could you give me another one, maybe? 4, 6. How about, is this one okay? 4, -1. How about this one? How about 4, -5? Is that okay? So the reason I'm putting you through this is because I'm trying to get in the way of the trap that your brain is going to try to throw you into. So what I want to do now, and I'm going to do this without graph paper because I want to make it so that you can sort of mimic what I do on your notes. So let's all make a little sketch. And all we need here is just simply y-axis and an x-axis like this. So again, a minute from now, you should be able to say, okay, I've made a connection. That's the goal. So if I asked you to graph the point 4, 2, where would you go? Mm-hmm. Okay, so I'm going to go right 4 and up 2. And let's just estimate what we think that looks like. It doesn't have to be perfect. But we should all probably know how to graph points, right? The x is the sideways number, and then we go to the y, which is the up. You've done this before. How would you get to the point 4, 6? Okay, so I'm going right the same amount, but I'm going to go up 6 instead of up 2. And if you haven't made the connection yet, that's okay. Let's do the next point. Let's go to 4, negative 1. So we go right 4 and then down 1. What's the next point? So I don't mean to insult your intelligence by asking this question, but it's absolutely mandatory that I do. What do you see? You do. You see a vertical line. It's as plain as day. Like it's unmistakably a vertical line. So you could graph now in your notes a vertical line that goes right through all 4 of those points. And you can then make a connection and you can say, hang on a second, if this is the only thing you tell me about the equation of my line, it's not y equals mx plus b. If I just gave you an equation that said x equals a number, you could make a connection now and say, I know exactly what kind of line it is, and I know exactly where to put it, right? Can you make a conjecture about any line that looks like this one that I'm vandalizing in yellow over here? What do you think is going to be true about x equals negative 3? Do you think the same thing would happen? Every time we make a point that has an x of negative 3, we would go left 3 and then something. Left 3 up 5, left 3 down 4, left 3 up 9, left 3 down. It doesn't matter. If your xness is always the same, then you have no choice but to make a bunch of points that are in a perfect vertical line with each other. So for our notes, we can add in a little statement. We can say this, and we can say this, I hope, right now with confidence. We can say, if an equation has only x, meaning there are no y's to be found, if the only requirement to be in that equation's like cool kid club is that you all have the same x's, we can say that if an equation only has an x rule, then it is a vertical line. Now, here comes the point where we try to figure out, like you say, well, why is this hard? This is why it's hard. For years, you've been taking math classes and you've dabbled in this idea of x-axis, y-axis. Which way does the x-axis go? Yeah, and therein lies the issue. Hundreds, if not thousands of kids in my classes before you have had this dilemma that they think, oh, he put x, I'm going to make a line that looks like x. It's backwards of that. If I give you an equation that just has x, you actually flip the script and go the opposite of that and go vertical. Does that make any sense at all? Because you're going to see equations starting today that don't have both letters. If you have 2 letters in your equation, you're going to get an oblique line. It might go uphill, it might go downhill, it might be steep, it might be wimpy, but it's going to have a tilt to it, right? But if you only have 1 letter, then you're in the funk zone. You're in the zone where you say, okay, this isn't like other ones. This isn't about y-intercept and slope. This is about me just hunkering down and saying, I got this. Okay. So if I said to you, graph the line x equals negative 3, all you would simply do is grab your ruler, you'd go over on the x-axis to negative 3, and then you'd graph a line like this. And in theory, you would agree that should be a very simple expectation, right? You would be amazed how often people get these backwards. And I don't lie to you. I just speak to you always from a guy who's done this for a while and is on your side. You would be amazed at how often I put x equals 5 on a graph, on a quiz, and kid goes up 5 and graphs this. Ah, dang it, man. Right? So keep it straight. So if you only have an x in your equation, you need to graph a vertical. You probably know exactly where this is headed because you're pretty smart people, but this time let's put a stipulation on our equation, but that only contains y. So let's say that y has to equal negative 2. And we'll go through the same activity, only it should go smoother this time. Can you give me a point that has y as its, or negative 2 as its y? I'll take it. That one fits the mold. He says, look at me, my y is negative 2. I'm in the cool kid club. Can you give me another one? Say it again. Good. Can you give me another one? Can you give me another one? Okay, good job. You just filled all of those in for us. And the key to every one of those is look at their y's. All of their y's equal -2, just like the rule says. Equations are just rules. Equations are requirements that say, if you want to be in my club, then you have to make me work. And to make that equation work, I just need that one thing, right? So same idea if we were to graph these, not if we were, we're going to. So when we graph these, the one thing about them that's all going to be true is that no matter where we go first, we're going to finish the job by going down 2. So to get to the point 4, -2, I would go right 4 and down 2. And you'll just see it happen right before your eyes. Like, it's unmistakable. How would you get to the point 6, -2? Right 6, down 2. How would we get to the point 1, -2? Right 1, down 2. We're going to finish we could do 100 of these, which we're not going to, but the last thing we would say every single time would be down 2, down 2, down 2. And you just can't fight it. If I graph Kaysen's last point here, -2, -2, you just cannot, you can't not see it. It's clearly a horizontal line, right? So we, at this point in time, could make a conjecture and add this to our notes. If your equation only has a y, that's the only letter you see is y. That's the only requirement to make the equation true, is y has to be something. What can you say about all lines that only have y? It is horizontal. And it's the same thing as far as, why could someone miss this? You sit there and maybe say, how could anyone miss this? Oh God, the reason why people miss this is because the y-axis goes up and down. You've been taught for years y goes up and down, but not this time. If it's y equals, it goes sideways. So if I said to you, graph the line y equals 4, where would you go? Don't you start with me. Y equals 4. We would go up 4. We would make a mark there, and then we would grab our ruler and we would draw a horizontal line. And then, of course, we would add arrowheads like this. Okay. Are we okay with that? I'm not going to make you like raise your right hand and solemnly swear, but I'm just going to tell you, I would be grateful if you could get that straight. Only X is vertical, only Y is horizontal. Now, the only other thing I wanted to talk to you about today was sometimes you're going to get y-intercepts that are not cooperative. And so I thought, let's talk about it so that maybe I don't have to go through it every single time it happens. So here is a graph. And let's say I gave you this equation over here. How about 2x minus 3y equals 8. This might look like you're like, hey, we've done this before. It's got a little twist at the end, and I think maybe if I get in the way of this, then maybe we won't have to talk about this again. So here we go. If I said to graph this, what would you do first? Yeah, it's a pretty normal answer. Let's get this 2x and move him to the other side. And remember that he's really just going to relocate himself to right where that arrow is pointing, right? So my next equation is going to say -3y equals what? No. And then what do we do to finish this? Good job. That was like in stereo. It was perfectly synchronized. We divide by -3. And now this is why this will be my last thing that I have to say. Well, maybe. And then it's just at the end, there's a little stress. So we get final answer. Y equals, what's the slope? Definitely positive 2/3. And then what's the y-intercept? Right. So here is, if you're still listening, which I know I'm getting to the point where I can't expect that anymore, but give me a couple more minutes. This is a problem because the slope, we like fractions. I love my slope as 2/3 all day, baby. Up 2, right 3. I love my slope when it's a fraction. I am not comfortable with that y-intercept. Because if I said to you, graph this line, where would you go to start? You'd go down 8/3, and then you'd ask yourself a question like, Mr. Ahern, how do I go down? So that's what this part of the lesson is for. I'm always telling you not to use mixed numbers, right? Use them now. Because I need, my poor little puny brain needs to understand what that means. If you tell people, hey, I need you to take 8/3 steps backwards, they're going to look at you like you're on crack. What did you just say? But if you ask them to take 2 2/3 of a step backwards, they'd say, I can do that. That makes more sense to the human brain, right? So let's do a little fourth grade lesson on converting. How many times does 3 go into 8? 2. The bottom stays the same. What's 2 times 3? 6, needing 2 left over. So the y-intercept in this case is going to be a mixed number. And now if I said, hey, Kaysen, I need you to go down 2 2/3, he'd be like, I got you. Watch my pen. I'm going to go down 1. I'm going to go down 2, and I'm going to just estimate 2/3 of the way to the next jump. Do you see that yellow dot? So when you get fractional y-intercepts, make them, if you have to, into a mixed number. Okay? Because it will help in this case. Generally, mixed numbers are bad news, but here they'll actually help us. And then from there, you can just graph more points. If it says the slope is, what, 2/3, so from there I go up 2, right 3, put another one. Up 2, right 3, put another one. You see? Nothing to it. Any questions on that? Case, Hagen, are you still with me, buddy? You doing okay? Have I just lulled you to sleep with this gloriously mellow math lesson? Yeah. Oh gosh, I know. You sound terrible. How about this one? What kind of line is this going to be? Oh, yes. It's a vertical line. And why do you know that? Because it's only got an X. You clearly understand today's lesson. This is a vertical line. I can't graph it yet. Why? Because I got to divide both sides, don't I? We're not going anywhere until we get X by itself. So let's divide both sides by -5. What does X equal? X equals -2. So if I said, hey, I need you to graph this for me, you would just go to your little cute grid and you would go to where X equals -2, which is, of course, to the left over here, right here. And then you would make a vertical line. Got it? All right. I think that's probably left something out, but who knows? So I'm going to hand out the worksheet. I'll keep the recording on in case anyone has any good questions that need to be given to the masses here. When you guys get to problem 8, the 5 is on the wrong side. And that's a little bit of a new twist. I get that. So what you have to do in this case is, well, first off, look at the TV. I want to get this red box by itself. And so I need to actually move 2 things to the other side, which you're really not used to. Don't worry, this will start happening more on Monday when I give you the hardest of these. So what happens is I take the 2x and I move it over. And excuse me. And then I take 5 and I move it over also. So my next line will say -2y equals what? Good. And now you should be back in your sweet spot where if you divide everything by -2, then you get y equals what? Positive 1x plus. And I realize some of you have just totally tuned me out, which is kind of creepy, but this is exactly what I was talking about in the lesson. And Gage, I'm sorry that I interrupted you because you were about to say it, but my bad. But this is what I was talking about. When I divide in this number 8, everything by 2, you go, wait, 5 doesn't divide by 2. So Gage, what is the y-intercept? It is 2.5. Very good. So that's exactly what I was talking about is when, and if you just write that down, I would advise you to still go back and work it. Like I saw a lot of you go like this and like, okay, fine, it's yours, but you're missing an opportunity if you don't go back and rework that, because that's good practice for you to see that the y-intercept doesn't always have to come out fluffy. Right. Great question there.